Supabase, the open source backend that does everything and makes Firebase look like it's still in beta. Database, auth, storage, functions, GraphQL before your coffee gets cold. It lets you store data in tables and views. You can store all your stuff in a bucket, and you can also lock in your users, keeping them safe. In today's video, we'll be covering everything inside a Supabase project: tables, where your core entities live; views, perfect for combining data across tables; storage, for handling files, uploads, and assets; auth, managing users and secure access; edge functions, your custom logic that runs at the edge; SQL, full access to your project's database; GraphQL, for structured, predictable queries; AI, intelligent, featured, backed by your data; and LLM tools, letting AI interact directly with your backend. In Supabase, everything you create, your database, storage, authentication, and functions, lives inside a project. Each project is a complete environment with its own keys, security, and resources, all neatly grouped together. You can think of it as your app's home, everything connected, everything in one place. From here, you can manage every part of your backend securely and without juggling multiple services. So here I am in my dashboard, and this is my organization here, and this is my project here, right? So if I click over here, you can see this is the only project that I have here. And if I select this, I can see all my projects, stats, everything here. And on the right-hand side, I have the different subsystems. These are the resources that belong to this project, okay? Now I can click over here and I can create a new project, and that new project is going to be isolated from this project. And so typically what you want to do is you want to assign a project to an app that you're building. So I have here this app over here, this agent builder demo. Well, all of these resources, they belong to this app. Okay. And so if I create a new project and I have a new app and people start using that app, I have users, I have clients, I have customers, that app is going to have its own set of resources, its own tables, its own databases, its own authentication, storage, edge functions, real-time, etc., that are not going to be shared with other projects in my Supabase account. And so you can think of projects as the main organizational layer where everything is kind of grouped under, right? It's kind of this umbrella that all the other resources kind of fall into. Inside each project, all of your data is stored in tables. Each table represents a single type of thing: your users, products, messages, or anything your app needs. Every individual entry is a record, each made of columns that describe its details. Add as many records as you want. Supabase keeps everything structured and searchable. Each entity in your app gets its own table, neatly organized side by side. A simple idea that mirrors how you already think about your data. Okay, so if I go into Table Editor, I can see all my tables here. And the beautiful thing about tables is that we're only interested in a single entity, okay? We're not thinking about complex data types or relationships or any of that, okay? So just to give you an example, here I have a bunch of tables, and I have some tables that are related to different apps. And so for instance, here, this is ecom products. And as you can see, this table is only about products, right? I'm not thinking about customers. I'm not thinking about orders. I'm not thinking about who these products belong to. I'm only thinking about products, right? On the other hand, I have here orders, right? And here I have a table having to do with orders, okay? And so this is only orders, okay? And I might have some relationships and all of that, but this is only about orders, okay? Another table I have is currencies, right? So if I click here, it's just currencies. I'm not thinking about converting these currencies. I'm not thinking about, what's the exchange rate or any of that. I'm just thinking about currencies. And that's really the genius with tables, is that we're only trying to store and represent and depict a single entity. Tables keep your data organized, but apps often need answers that span multiple tables. That's where relationships come in. Define how tables relate so you can pull the exact data you need. No duplication, no chaos. The system for this is beautifully simple. There are three kinds of relationships you can create: one-to-one, where one record connects to exactly one other; one-to-many, a single user linked to several orders; many to many, products link to many orders, and orders back to many products. Foreign keys connect tables. One column references another table's primary key. With just these three relationships, you can model nearly any real-world scenario. Now, this table, it has a relationship to a currency table, okay? Because typically a country has a certain currency, right? So let's say we're looking at a country called New Zealand, right? Well, New Zealand has a currency, and if we click over here, we're going to have this record that's in that currency table, right? And I can open this table, and now I see this record in this currencies table, and this specific record is linked to a record here. Now, in this example, this is a one-to-one relationship because each record here is linked to exactly one record in another table, right? So if I go into France here, and I click here, I'm just going to see one currency here. I'm not going to see multiple currencies. And if I go into currency here, I'm not going to be seeing multiple countries on the other side. Every single record is linked to a single record in the other table, right? If I go into Japan, guess what? One currency. If I go into China, guess what? One currency, okay? And if I click here and I open this up, open this, I'm going to see one currency. But if I go back to countries, this Chinese yuan is only going to be linked to one country. It's not going to be linked to multiple countries. And that's because this is the first type of a relationship. This is a one-to-one relationship here. Of course, you can have other types of relationships, right? Just by having one-to-one is not enough. You might also have something called a one-to-many or a many-to-many. So an example of a one-to-many is, for instance, if I have multiple orders, right? So if I go into my e-com orders, and I have this customer ID here, well, that customer might have multiple orders, okay? So for instance, we have here two orders linked to one customer, okay? Now that's a one-to-many relationship because you cannot have that specific order linked to another customer. That order can only be linked to me. It's a unique order, okay? That's a one-to-many relationship. On the other hand, a many-to-many relationship would be something like a customer and a product, right? So I can order multiple of these products, and another customer might order multiple of these products. So if I go into a store and buy apples, oranges, tomatoes, well, guess what? There could be another customer that may buy oranges, tomatoes, and the same products that I'm buying. When you have that situation, you have something called a many-to-many relationship. So I can have, I can buy tomatoes, oranges, and apples, and tomatoes, oranges, and apples can be purchased by many other customers. Okay, so there's that dual relationship, right? On the other hand, here, an order is unique. It can only belong to one customer. So I can have multiple orders, but a single order can only belong to one customer. And that's a one-to-many relationship. And that's how one-to-one, one-to-many, and many-to-many relationships differ. And they allow you to create all kinds of interesting and intricate relationships to model pretty much any kind of data situation. Files don't fit neatly into rows. Tables reject heavy uploads, forcing a better solution. Storage gives files a dedicated home. Buckets keep everything organized and easy to manage. Buckets act like folders, create as many as you need, and keep file previews right where you expect. Set buckets to public or private, assign permissions, and Supabase enforces access automatically. Generate signed URLs for private files. Share temporary links that expire when you decide. Buckets, previews, and access controls come together for simple, secure file handling. Right, so if you head over here, you can see that you have files, analytics, vectors. You also have your configuration. But on this main screen, this is where you're creating something called a bucket. Now, what exactly is a bucket? Well, a bucket is like a table, okay? A bucket is a way to organize your files. So if I click over here, I can create a new bucket. I can specify whether it's a public bucket. I can restrict file sizes. I can also restrict MIME types. This is a way to restrict to only certain types of files that can be uploaded. Okay, so if I click here, public bucket, and I say this is, let's say, bucket 1, I can click on create over here, and that's going to go ahead and create a new bucket where I can click on and I can upload files. And so I can drop my files here or upload them via the upload file button above, right? So if I go over here, I have my upload files. Now inside this bucket, I can create folders, I can organize files further. But the key with this bucket is that I can edit bucket settings, right? I can also create various policies on this bucket. I can configure it in ways that will get this bucket to behave differently from another bucket, kind of like with tables, okay? You can have tables that store certain data, and same thing with buckets. You can have buckets that store certain data that needs to behave in a certain way. So whereas tables are for storing structured data, buckets are for storing unstructured data. Tables keep everything tidy, but everyone can still see everything. RLS lets you decide exactly who can access each row. Match each row to its owner. Every user sees only their own data. Decide how each user can interact with their rows, read, insert, update, delete. Filters turn RLS into a smart view. Only the rows that matter remain. With who, how, and what rules, your rows stay secure by default. RLS, which stands for row level security. Now, right now I have it disabled, but if I click over here, I can enable it for this table. And when I do that, I need to create policies because by default, everyone will be denied access to this table. And so here I can click on add RLS policies. I can click over here, I can create a policy, and here I can specify how, who, and what with respect to my data and what kind of users can access it. So for instance, on the right-hand side, we have some templates. So things like enable read access for all users. I can click here and guess what? Now we'll have read access for all users. Enable insert for authenticated users only, right? So if you're logged in, you can insert. Enable delete for users based on user ID. Enable insert for users based on user ID, right? So you can make your security policies as granular or as fine-tuned as you want. Now, if none of these templates are designed to do what you want to do, you can create your own policy right here. So for instance, I can say select to only authenticated users, or I can say all can do whatever they want to do, or I can think about who will have the right to insert new records, or who will have the right to update or delete new records. Okay, now this is not only applicable to tables. You can also do that with storage, right? So if I go into storage, I have my bucket here. I can go over here. I can create policies on this bucket, right? So I have this policy, and guess what? I can create a new policy, right? Get started quickly, and I have my templates here. Or I can go over here and I can create a new policy, full customization. So same thing, I can specify who can view data, insert new files, update files, or delete files. And once I select this, I have these things being selected here, right? To signify which operations are going to be allowed, right? So insert, delete, all of this. So for instance, let's say I do insert and update. Well, these ones are the ones that I'm affecting right here. And I can come over here, target roles, a non-authenticated service role. And here I can have my policy definition. I can provide a SQL conditional expression. So I can make it as specific or as general as I want, depending on what I'm trying to do. And so this is a great way to create secure policies to your tables as well as to your storage buckets. Without authentication, every request looks anonymous and impossible to trust. Authentication gives every user a unique identity, so you always know who's logged in. Choose exactly who can sign in, open access, invite only, or restricted domains. Let users sign in the way that fits best: passwords, magic links, codes, or OAuth providers. After sign-in, a secure token proves who the user is and only their rows unlock. Authentication plugs into your database security so identity, RLS, and data all stay in sync. So if I want to create a new user, I can simply click over here. I can send an invitation, james@james.com. I can use a strong password here, and I can select this if I want to auto-confirm the user. When I click here, that's going to go ahead and create a new user that's already confirmed with the password and everything. But that's not all. I can click over here and I can go into my sign-in providers. And so I can get users to sign in not only via their email here, which we have enabled by default, but also via their phone, via their Bitbucket account, Apple account, Azure account, Discord, Facebook, lots and lots of third-party providers with which your users might already have accounts. Okay, and so if your users have accounts with, let's say, Google, which is a very, very high possibility, you can simply click over here and you can simply set all of this up, configure it, and when your user is trying to log in, they don't need to create a new account, and they also do not need to log in with their password. And they can simply log in with their Google account. And if they're already signed in with their Google account, they don't need to do anything. They just need to say, hey, I just want to sign in with my already signed in Google account into your app. And your app is going to know exactly who the user is. And you can combine all of that with your database, with your storage, with your secure policies, and this way it can become all nicely integrated together. Without a built-in runtime, teams juggle cron jobs, ad hoc scripts, and brittle webhooks just to run logic. Edge functions give you a managed runtime. Ship custom logic once and route every trigger through it. Schedule functions, respond to HTTP, or react to database events. Choose the trigger that fits the moment. Edge functions handle the tasks your database cannot: payments, notifications, sanitization, moderation, any workflow you need. Edge functions run from Supabase's global POPs. Deploy once and your code executes close to every user. Edge functions sit inside your Supabase project, sharing events, secrets, storage, and database connections instantly. Edge functions close the loop, enforce rules, fan out work, and respond instantly on every surface. Now, if you click on Edge functions in the menu, you're going to be on the screen here. And this is where you can create your custom logic, your custom code that has complete access to pretty much everything inside of this Supabase environment. Okay, and so you can start with a template. You can work via an editor. You can have an AI assistant. You can also work via the CLI, which is the command line interface. And so if you click here on the simple hello world example, you have this simple hello world function. And if you scroll down, you can deploy this function right here. So if I click here, that's going to go ahead and deploy this function. Okay, so it says here, successfully deployed my Edge function. And now I can call this function, right? So I have all of these controls. I can call it from a curl request, JavaScript, Swift, Flutter, Python, you name it. But the beauty here is I have a piece of code that's running server side. It's not running on my app. It's not running in my front end. It's not running on my mobile app. It's running where Supabase is running. So with Supabase, I have a custom piece of code that has complete access to my entire environment. So I can easily, edit a table, check out my database, do some authentication stuff, storage, you name it. It's running as part of my environment. And this is great because that means you don't need to have code that's running somewhere else. So you can essentially standardize and centralize all your logic pieces to be Supabase Edge functions and have them running here. When you need to get data, REST points overfetch, underfetch, and force brittle views when you just need one clean payload. GraphQL replaces brittle endpoints with one glowing entry point where you ask for the exact shape that you need. Select the exact fields you want. GraphQL streams only the requested columns back to your UI. Nested queries pull user, posts, comments in one request. No extra endpoints, no follow-up calls. UI screens stay in lockstep with the query. Dashboards, feeds, and profiles map directly to requested fields. Supabase auto-generates your GraphQL schema directly from tables. No resolvers, no extra plumbing. One query, one clean pipeline. GraphQL keeps data precise, predictable, and powerful. Now, to enable GraphQL, you want to go into here, integrations, and you want to make sure this GraphQL here is installed and enabled. So as you can see, it says installed GraphQL. Now, if I click on GraphQL and I click on GraphQL, I'm going to be in the so-called GraphQL IDE, which stands for Integrated Development Environment. And here I can access all my data. So I can simply start typing and access all my tables. So let's say if I go back into my table editor here, and let's say I want to access EA countries. Well, I can go back to my integrations, GraphQL, and I can just start typing countries. So if I do that, it pulls up my table. So I have here countries collection. And here I can do something called an edges. I can go over here and then I can do a node. And then I can say country, right? So let's say I want to list country ID, okay? And so that right there is going to list the country IDs in that table. So if I click here, that's going to go ahead and execute the country ID. I can list more stuff, right? Because I have more data, right? So let's say I want the ISO code as well. Well, if I run that, now I have the ISO code, NZ, FR, SA. But remember, we have relationships, right? So if I click here, I can do other stuff. I can say currencies, right? I can do currencies. And inside of currencies, I want to say the name. Okay, and now we are doing relationships automatically. Remember, we have a relationship, a one-to-one relationship where each country is linked to a currency. So I don't need to do fancy joins or create views or anything like that. I can simply get the data that I want. It's called declarative. I'm not worried about how I'm getting the data. I'm only caring about what kind of data I want. So I can go further, name, and I can do code, right? So this is the code for the currency, the ISO code for the currency. We have the country, and it's a one-to-one relationship. So we have New Zealand dollar, France, euro. Here we have Saudi Arabia, rial. We have Great Britain, British pound, etc., etc. And so GraphQL is amazing. It's one of the best kept secrets when it comes to using Supabase, and that is because it allows you to choose and pick the kind of data that you want without worrying about relationships, joining tables, creating views, and all of that. You just specify what kind of data that you want, and it figures it out and it delivers. Supabase gives you the full backend, but juggling databases, auth, storage, RLS, and functions gets complex fast. Imagine building tables, inserting rows, or deploying functions just by describing what you want in plain language. LLMs understand your instructions and translate them into precise actions, perfect for orchestrating Supabase. LLMs are powerful but blind. They can't help unless they see your schema, policies, and functions. MCP, Model Context Protocol, bridges your AI and Supabase, a secure highway for actions. Supabase can expose every backend action as MCP tools, tables, queries, storage, functions, all AI controllable. Your LLM becomes an MCP client. You talk to it, it talks to Supabase, actions happen automatically. MCP defines tools, Supabase actions, and clients, LLMs. It standardizes how they communicate securely. Supabase plus MCP plus LLMs, a backend you can talk to, plan schemas, run queries, deploy logic with plain language. Now, when it comes to using AI, there are two main ways that you can use AI with Supabase. The first way is by using this AI assistant. So if I click over here, I can chat with it. I can ask different questions. I can say, hey, create me a query that gets all the currencies. So the first thing I want to do is I want to click on permissions and I want to give it permission. So I'm just going to give it all the permissions. Next, I can ask it anything that I want about the tables that I have. So for instance, I can say something like list all the currencies in the EEI currencies in my currencies table. Okay, and if I run that, it should figure out that I have a table called EA currencies, and it should hopefully find it and list me all the records here, right? So it did list tables. Okay, so I found the table. There we have EA currencies. Confirm which table that you want. I have two tables that kind of look similar. So I'm just going to say that I want EA currencies. Okay, and it's going to go into that table. And it's going to create a query. And so it's going to get all the data. So I'm going to say run query. And it's going to pull up all the data. Okay, so you can use this AI assistant to do pretty much anything that you want when it comes to having your data. Okay, and you're primarily going to be running this AI assistant inside of Supabase. Okay, now the other method of connecting to Supabase with AI is by using something called an MCP server. So if you Google for MCP Server Supabase, you're going to end up on a page that looks something like this. And here, you can configure your MCP server. And what this means is that you can make your Supabase instance available to other LLM agents. Okay, so if I have this project here, I'm going to select this project, and I'm already logged in because this is still Supabase's site. This is their documentation. So it knows I'm logged in, right, as the case was here. And so here it gives me this URL that I can configure my AI agent, right? And so depending on if you're using something like Cursor, VS Code, Windsurf, Claude Code, Codex, you name it, anything that supports the MCP protocol, you can simply give it this and it'll be able to communicate from inside your LLM. So whereas here we are using an LLM inside of Supabase, this allows you to use your LLM and connect to your Supabase from an LLM. Okay, and this is great because if you're using an LLM to do something, maybe write code, generate images as a basic chat functionality, asking questions, etc. When you configure this, you can simply ask it to give you data that's in your Supabase database, and this makes it super, super useful by closing this loop. And that means you can stay in your LLM without needing to jump into your Supabase to look something up or to do an operation. Now, I really hope you've gotten value from this quick but value-packed Supabase tutorial. If you like these kinds of videos and you want to see more of them, definitely hit the like button, leave a comment below, and check out our amazing Patreon community for more content and for more value.